Okay, so hello and welcome to another wonderful Strayos webinar, How Drone Data is Simplifying Boretraking Operations, hosted by Strayos and presented by our excellent guest speakers, Maine Drilling and Blasting's Aaron Flewelling and Zadok Emerick. Before we get started today, we have just a couple quick housekeeping items to mention. Please try to put all questions in the questions section of your screen. It's easier for our presenters to keep track of them there. We have reserved some time at the end of the presentation for some question and answers. Feel free to ask as many questions as you want. We will be sending out an email after the presentation with the link to the recording and the answers to all of the questions asked. If you would like a certificate of attendance, please email hello@strayos.com. I will put all of these in the chat bar also. Finally, there will be 3 poll questions during the presentation. We would love to hear from everybody if you're willing to share. Thank you everybody for joining us today. And without any further ado, Ravi Sahu.
Thank you, Kim, for the housekeeping items and the introduction. Appreciate it. And welcome, everybody. It's great to have you here and interacting with everybody from different time zones and different countries. My name is Ravi Sahu, founder and CEO of Strayos. And today I'm really excited to talk about and having Aaron and Zadok talk about drone data integrations with the boretracking operations. So the topic for today is how really drone data is empowering boretracking operations. And in that, we will see a variety of really interesting topics here. So here is the agenda for today. We are going to start with just a quick introduction about the company and why use drone data for boretracking, what is boretracking is and why should we do it, some real examples, and also the implementations steps and what are the logistics that is required to implement and the team dynamics and the challenges as well. And finally, we will review these steps for the implementations and how you can make that a success story. And we will have a Q&A at the end as well. So make sure you are putting all your questions in the question box as we continue the presentation. Bit more about Strayos. The company was founded in 2016 and with a goal in mind to build the best of the breed solution for the mining and quarry applications. And since then, we have evolved into 600 plus quarries and mines with roughly 50 customers in 8 different countries. One of the things that we take pride in our customer support, and that's why we have a global presence and global team that we have built in America, Asia, and Europe to support 24/7. And some of the metrics that we have been tracking is so far we have processed up to 75,000 drone data projects, in our platform, rolled out 50 plus AI models with up to 50 million imageries has been analyzed in the platform, which has resulted into various savings and improvements for the drilling and blasting applications. We provide mine to mill as a solution, where we touch a variety of solutions, starting from your surveying, how to use your data collected from the field, bring it into the platform and process and generate those digital twins. And then further, it can be expanded into a variety of AI and the detection use cases and the analytics like geology detection, drill planning, and then you can apply it further into the blast design process as well, expanding it further into the loading and hauling inspection side, and the fragmentation measurements can be done in one place, along with the inventory reporting and the generation of overall metrics for your quarry or mine. So essentially having a true pulse or true health of your mine and quarry that you can analyze in one place. The workflow is fairly simple. What you do is you collect the data, upload into the platform. you have a design tools, you can use it and then further interpret and report for your decision making process here. So that's a bit more about Strayos. With that, we will open up our first poll question. We're very interested to see your responses here. So the first poll question is live now. We'll take about a few seconds here to see what you guys think about this. Great. I see pretty balanced responses. Bit of a time going on right now where everybody is doing the measurement of the as drilled hole deviations. Sometimes almost 40% has not started yet. So, all right, I think we are getting to a good, let's see, still somebody are entering here. So great. So we'll end it in 3 seconds. So thank you very much for your responses. With that, we will. It is my pleasure to introduce Aaron Flewelling, Manager of Engineering and Technical Services at Maine Drilling Blasting. Aaron has been leading this group since 2010. During his tenure, Aaron has been involved with the estimating through completion for hundreds of drilling and blasting projects throughout the Northeast and Mid-Atlantic markets. He began managing the department in about 2018. The engineering and technical team that Aaron leads has grown to 25 employees performing tasks such as boretracking, surveying, estimating, takeoffs, blaster education and training, and technical evaluation, among other assignments. Welcome, Aaron. And another guest speaker, we have Zadok Emerick. He has been with Maine Drilling Blasting since 2018. Zadok has been responsible for training and mentoring the current boretraking team for 5 technicians. He has performed over 1,000 drone flight deployments and boretracking system using Strayos. He evaluates new products and deployment methods for the team to ensure efficiency in operations are maximized here. Welcome, Zadok. Over to you guys to take it here.
Sounds good. Thanks, Robbie.
Thank you.
So I'll start a little about the company. So Maine Drilling Blasting started in 1966 as a family business in Gardner, Maine. So probably safe to say we are in the U.S. only. In 2004, we became an employee stock owned company. So the employees own the majority of the company, which kind of attributes to our need to always look for more efficient ways to do things, and kind of what led us to Strayos. So quarry and construction projects throughout the Northeast, Mid-Atlantic, and Southeast regions. So the next slide will have a little map here, but we're involved in the quarry and construction markets. So here are office locations. Zadok and I are actually down in Milford, Mass right now, but pretty much the Eastern Seaboard, and then down into Nashville. That's our market right now. We started using Strayos and drones in 2018 due to the rising costs in the 3D laser repairs and a need to find a better and more efficient solution. Just to give you an idea, that polling question, we're probably bore tracking at probably 90% of the shots right now. So we're, heavily using Strayos. So the first year we started using it, we had 4 technicians, did about 1,200 flights. The next year we're still getting our feet under ourselves, and got it up a little bit to 1,300. And then last year, just the efficiency that we've been able to find using it, getting to more places, we get more requests for the service, and we added a 5th technician, and with that almost hit 1,900. I would expect this year we'll probably be over 2,000. We've kind of got another person that's helping out with some of the overload right now. So next slide.
Yes, now we have another poll question here. We're interested to see about this next question, what you guys' responses are. So we should be live in about a few seconds. Very interesting responses. So we're going to keep this open for another 5-10 seconds. Yeah, surprisingly, laser scanners we haven't received any response there. So I was hoping that majority of them using laser scanners. So that's interesting there.
Well, now you can get the ones that don't bore track at all and tell them the right way to do it from the beginning. No bad habits to correct.
Yep. Yeah, don't
Great.
spend your money on the lasers.
All right, so we'll close this poll question. Thank you everybody for participating. Move on to the next topic here. Over to you, Aaron and Zadok.
So just a little background kind of on, what bore tracking is. It measures, deviation of your bore holes. Primarily, we do it on our face holes, which, first row of the shot against the exposed face. Occasionally, we can get into, second, third row, or in some cases, even entire shots if there's, serious deviation problems. The probe's lowered down the hole, and it measures the pitch and the roll. And we usually do it at about 2-meter intervals on our way down. And this creates a pretty accurate representation of what that hole's doing. Compared to the surveyed 3D model, we can then go in and plot these holes on the model that we create on Strayos from our drone data. And you can see in the photo on the right there, the actual holes plotted on a bench, and the lines in front, kind of the zigzag lines, are showing the, where the thinnest burden is, that hole at each point as it's coming down. So this has been a huge tool for us in the blasting. Being able to prevent fly rock, knowing if there's not enough rock there, and preventing, overloading a hole, putting too much product in it. And at the same time, we're also able to improve our fragmentation because we're able to put the correct amount in all the time. And sometimes, we can be certain exactly how much rock we have and load the hole accordingly to get the best breakage possible while still being safe.
Great.
So we have a couple examples here, just kind of how bore tracking's been useful for us. So this is a quarry that we have down in Connecticut. It's some pretty tight quarters where, this face that we're looking at here is actually about 400 feet off of a 4-lane highway and about 100 feet off the building that the quarry owns. So you can see here holes 30, 31, and then 34 and 35 there are all very close together. Those holes did not go where they were intended to. We ran into some deviation. This is a pretty deep cut. These holes are about 70 feet deep, and the geology is quite challenging, the way the rock lays in. So it's not uncommon to see results like this. But holes 31 and 35 are about 2 feet apart at the bottom of the hole. And, that can be a serious issue in such tight quarters if you don't have enough burden at the bottom of the hole. You can essentially turn a 4-inch hole into an 8-inch hole, and there's twice the product you intend there to be. So that was, a big save for us. Luckily, we did have enough burden, and the shot was, we were able to shoot it safely. But this was, a big tool that allowed us to do that. This is actually the same shot. It's just a different view of it from the front, showing the burdens. And you guys can see kind of right in the middle where there's that big V where the 2 blue lines are. At the bottom of that, you can actually see those 2 holes that we were talking about. There's a red dot and blue dot that are almost right on top of each other. And that's the 2 holes. It's just a good way to show how close together they really are. And this is just another example, a place that has been a very challenging account over the years. It's a big pit up in New Hampshire, and kind of due to restrictions based on the customer, we shoot extremely deep cuts at this pit. This current shot, these are about 110-foot holes. And you can see from this picture how bad the geology is. The biggest kickers here, those holes are going out about 30 feet. So as opposed to doing just the first row like we normally would, this shot we boretraked, what would actually be the first 5 holes or 5 rows, because there's so many kickers and we had to do so much, to make sure all these holes are where they're supposed to be. And, this just shows that this driller did a really good job. We got holes kind of scattered all the way through this. Should be able to get good fragmentation and achieve the results we're looking for throughout this whole shot.
Now it's time for another poll question here. So we'll make these 3rd question live and the final one. The 3rd question is a very, I think that's a super interesting for me, and for probably also just in industry perspective. What's your biggest challenge that you are facing in adding boretracking to your operations? Very balanced opinions at the moment. And so we'll give another 5 to 8 seconds and we'll close this call as well. See, there's one more responses coming up, few more. I think we are good to close now. Thank you everybody for participating in our 3rd and final poll. We appreciate your engagement here. Thank you. So now we will transition into the next part of the discussion and the topics here, which Aaron and Zadok will cover. What it looks like, the challenges that is, for the present, for the implementation of the Boretrak program here. And personally, I believe that Maine Drilling Blasting have done a tremendous job in not only is developing a training program, but also developing the right procedures here. So I'll let them walk through this.
So obviously, it can be challenging trying to get a program like this started and, implementing it throughout your company. One of the biggest challenges that we face day to day is the fact that the bore tracking has to be done after the drilling, but before the load crew arrives, before we go to blast. And, with enough time for the blaster to be able to review the information and make sure he knows what he's getting into before he shows up that morning. And I'm sure, as everyone in the industry knows, a lot of times these customers, they want you loading the hole the second that last hole is drilled because they need the rock. So it can be challenging trying to get everything coordinated correctly. And, sometimes it means late nights or early mornings to make sure everything's done. But, it's definitely pays off in the long run. It's been very beneficial for us. Obviously, the equipment, it can be, a little expensive starting up, but, with Strayos and being able to use the drones, it's significantly more affordable than it used to be. I believe, we were paying almost $40,000 for a 3D scanner. And, when you compare that to the cost of a drone is and how much more accurate and easy to use the drones are, it's really a no-brainer. And it's nice that, a lot more people have had access to the technology at this point. Training, I know a lot of people, get nervous about it. It's difficult to get started. You need to get someone that knows what they're doing and knows how to use the equipment to kind of get your feet on the ground and get rolling. Everyone has been super helpful with us in the transition. Robbie was great in, learning how to fly benches and how to, correctly capture the data to get us our most accurate product. And once we got started, it worked out really well. We were able to train other technicians internally and expand the team and get, a lot more people doing it. And like Aaron said earlier, we're now, all the way down to Tennessee with technicians active all the time and covering a large area.
Great.
Yeah, and really at the end of the day, it can be expensive, but one bad fly rock, can cost more than putting the whole team and buying all that equipment and everything else, and let alone reputation and just the actual cost of it. So it is something really worth it. We've been doing it since somewhere in the 90s, and kind of progressing as technology, not that new technology comes up that often in bore tracking, but when it does, we try to be the first ones on the, on the bus to try to get our heads wrapped around it. And so we've, for a long time felt it was a valuable tool. Next slide. So here's a couple of things that we have started to do that kind of made this possible. Because the technology, the tools are so specialized, we've really found that putting that group as kind of a team and siloing them together has been beneficial. We for a while kind of had somebody out in New York, somebody in Massachusetts, somebody down in Pennsylvania. They all kind of worked independently, and there was a lot of things lost in between, or somebody would learn a lesson the hard way and the other people wouldn't know about it. They'd have to learn the same lesson. So definitely getting that group, kind of acting as one, if you will, and having dedicated trainers. That's kind of been Zadok's role over the last few years. It makes the continuity, in the training and the knowledge that much better. Evaluation by a single dedicated team leader. So same thing. When there have been new people that have been trained, maybe not by Zadok, but other higher level team members, Zadok's always the one to make sure that they know what they're doing. They're doing things just the way we should be training and things like that. So going through that process and kind of a final check, we developed a spreadsheet that just kind of has a checklist of everything they should know how to do, and we just make sure we evaluate that. And then obviously using the drones to speed up 3D model capture, and using collaborative cloud-based platforms. So it's nice when people do have issues, to be that cloud-based platform. Somebody else can go in and look at the problem they're having, or even we call Ravi. He goes in, looks at it, and tries to help us out. So, not having to deal with, sharing files back and forth and things like that makes a huge difference. So successes and a lot of the reasons we switched from the 3D profilers is the one-person operation. So, it's Zadok can show up on a shot, do everything himself. The drone is a one-person operation. The boretracking is a one-person operation. You don't need the second person holding a reflector on the holes if that's how you've been doing it. It's definitely beneficial. Data can be uploaded and processed while driving between sites. So it says over on the side there, with our 5 people, we can do up to 20 sites a day. So you do the math, that's 4 sites per person per day. That'd be maxed out, but we probably had those days where that happened. And so a lot of our sites are an hour to 2 hours or more, even in between. So, that time they're driving, they can be processing the data. And then at the end of the day, you can kind of go through and get all your reports sorted out. Quarry planning and surveying is completed in a fraction of the time. So on the engineering side of things, a lot of time was spent previously doing on the ground surveying, with GPS, toll station, things like that. So there's a huge savings on that side of things. Sometimes we'd spend days at a certain quarry to, get face locations and things like that. And, now you can fly it in 20, 30 minutes with a drone and be, just as accurate and be able to, put your quarry plans and things like that together, get updated, faces throughout the year, things of that nature. And then obviously safer. So when you're running even a 2D profiler down on the floor, there's usually quite a bit of activity going on, loaders, haul trucks, things like that. And then you've also got somebody up, close to the face if they're holding a reflector. So, less time you can spend out there, the better, and the less time you spend on the floor is better too. So, yeah, it's quite a bit safer. Drones are obviously much cheaper and easier to repair than 3D lasers. So Zadok mentioned, the cost of the 3D lasers, and drones, depending on what you're getting into, is $1,500 to $2,000, a little bit more depending what you want to get. But so yeah, and much easier to repair. If you do have one go down, you can probably go to a Best Buy or a store, pick one up, order one, whatever, versus a lot of the specialized equipment, you got to send out to a certain location. You got to wait, usually weeks to get it back. And because it's specialized, it costs a lot more to repair. That was our big thing, was just the repair bills were getting to the point, we were paying, enough in repairs to buy a whole fleet of drones every time we sent one out. So it definitely wasn't working out. And that's kind of what drove us to start looking and find Ravi. So.
Great. Well, thank you, Zadok and Aaron, for the wonderful presentation. I learned a lot about, not only about how you do your operations, but more importantly, I think those real examples that you showed, that was definitely eye-opening for me, how complicated the situation can get when you are blasting. So thank you for sharing that, and I hope that was useful for everybody in the audience as well. So now we will open up for the Q&A here. Feel free to post your question in the Q&A chat box here, and we will start answering those. Before we dive into the audience questions here, there are a couple things that I am very curious to learn more. And one of the questions that I have is, what are kind of all the steps that you take at the moment after the boretrak data is acquired, and how do you upload that into drone 3D model, the more integration process of the boretrak data into 3D model?
So, after we get the boretrak data, well, actually, even, before we get the boretrak data, usually the first thing I do is, I'll number all the holes and then fly the drone and get that data processing and get the model, loading. Then boretrak, get the data, and that all gets uploaded to our computer. We have a program that, converts that raw data into a text file, and then we upload the text file directly to Strayos. It's super easy. Everything, it's kind of one stop. It's nice that it accepts just the text file. And as soon as you hit the upload, you select whether it's, a cabled system or a rotted system. And I'm looking at the bench that I just flew. And it's as simple as telling it, you kind of tell the software where you are, which direction you're going. And then I'm just putting all the holes down in the order that I boretracked them. And, it is just that simple, clicking through, and, you double click the last one and you're done.
Okay. Sounds so really simple. So thanks for sharing that, your workflow. Another area that I am constantly learning how to develop some best practices and how other members in the industry use the drone to fly the face. What have you seen the best practices at your organization, which results into so much, the not only the agility in the data collection, but every time the data is being generated is very consistent. So if you don't mind sharing the best practices and procedure for flying the face.
So I've found the best thing that works for me, over the years, kind of learned the hard way here and there, but finally kind of got it dialed in. I do one pass over the top of the shot with the camera straight down at 200 feet. And then I'll drop down to about 80 to 85 feet and do 3 more passes, kind of staggering your way back from the shot. So I'll start over the first row, go back across over the second row, and then again up over the third row. Then you actually fly out in front of the shot and look back towards the face. And it's kind of, at this point, all has to do with the camera angle. So the key is to capture the toe and the crest of the bench with, a little bit of overlap on each side, but not too much. I've found that the camera at about 65 to 70 degrees is kind of your sweet spot when you start there. I'll do one pass across the face like that, and then I'll back out a little bit, go a little bit lower, do the camera to about 45 degrees, and do one more pass across that face. And, that's the best way that we've found. It's created very accurate data and replicable data.
Great. Do have a follow-up question on this. And so it seems like all your technicians are well trained and they are able to replicate this procedures in all their flight captures. How long usually the flight times are being in general for this method?
Probably only 5 minutes at most. It
wow.
all kind of depends on the shot size, how long it is, but even a very big shot is probably only about 5 minutes of flight time.
Great, amazing. Now we will pick up some audience questions here. The first question we have is from Walter. Are you boretracking all the holes on the shot or only front row perimeter holes?
Generally speaking, it's just the front row. Occasionally, kind of like the photo that I showed, occasionally we'll do, second or third row as well if it's needed Sometimes a blaster will call me and request it, ask me to do more. We do actually have a couple accounts, throughout the company that require bore tracking on every hole, on every shot. So, when it's up to us, it's generally just the first row. That's the most important, but by discretion, we'll do more sometimes.
Okay, thank you for the answer. We've another question that goes back to more on the presentation itself. There are a couple members of our same question. Could you describe what we are seeing in the pictures? What are the visualizations, interpretations are? So maybe I can go back to the specific slide, and essentially the question is related to how these directions, what are these visualizations or the directions represent here, potentially this?
Well, so the first one you were doing, the number is the top of the hole. That's the collar of the hole. And then there's that small dot off to the side is where the hole ends. So that just kind of shows you the direction it's going. And, you have your top and bottom. You can go back to the other one, Robbie. This one is showing, each hole actually that we plotted on the bench. And all the squiggly colored lines up here that's what's actually showing, your burden. So that's your 3D burden on each hole. And the reason they're so squiggly and, zigzagging around is because that's the thinnest point from that hole to out, anything that's not rock. And they're color coded. This is just kind of I think this is the default one. Anything that's under 5 feet is in red. If it's close at 10 feet, it's green, and then blue is 15 feet or more. So you can it's nice to be able to see just like the visual representation, quickly on, if you're too thin, if it's all red, you got some problems right off the bat before you even go any further.
Yeah, and just to expand on this, the 3D burdens is looking at 360-degree, more of a spheric view where the critical path or the least path of resistance is, and it's finding those weak points in a whole length here. So that's what this representation is visually that has been depicted here. The numerical information can also be found into the tabular view, which is in the left panel side. And the next one is essentially the same representation, but it's in a different angle here or a different data set.
Correct.
So we have another question that's more a clarification instead. So the question is, are we combining two processes, using the tracker to put in the borehole to collect data, then use drone to capture imagery and do the 3D modeling? Then the second step is processing together, combining the imagery and the borehole sensor data. So please correct me if I am misunderstood. I think I can take up this question here. We are essentially, the first step is you can do it independently. You can measure the borehole with your bore tracking device, which has gyroscope and some sensoring system, which will let you collect the data downhole about the deviation. That generates essentially information from the devices. It can be exported as a text file or a ASCII file or some raw file. You use that file now to upload that into a drone model. So you're not processing together, you are simply integrating, or you're simply uploading that into a 3D model, which is usually just uploaded, and you after that click, you can find the whole positions from there. So that's the workflow here. So there is no processing required. The only step that you are taking is collecting the data, exporting it from the boretrak device, and then flying the drone to capture the pictures and generate a 3D model, and combining these two data sets together. Great. We have another question. It's more related to, so the two main benefits of the bow tracking is to know the hole direction and to know the rock type and volume, so as to know what amount of chemicals to use in blasting. So that's the question here.
Yeah, so definitely for us, the main benefit is the hole direction and the deviation. So, this picture you've still got up here, we see 20 feet of deviation in these holes. The risk is that those holes get very close to the actual face. And if you don't know that, when you load explosives, with not enough burden in the front, you can create a fly rock. So, the risk is trying to mitigate that exposure from the fly rock. So Boretraking the holes will tell you that. That's predominantly, what we're trying to avoid and the benefit there. And like we said earlier, you obviously can get better breakage if you're confident in where the holes go. We've got some accounts that we really need to, put as much explosives as we safely can in the holes to break the rock. And so, if the blaster's not confident, he's going to be more conservative with his loading. Maybe do some taper loading at the top where, or at a shallower depth or deeper depth than he needed to. So it's a big peace of mind tool for the blasters more than anything. And kind of relating to your last part, it definitely can play into the amount of explosives and what type, if we're using stick product to taper load at the top versus, bringing the bulk up as high as we can. It definitely gives the blaster kind of a roadmap of what the holes are doing, where they're going, and how much rock they've got in front of them, to be able to safely load it.
Absolutely. I do have a follow-up question on this because it's just dawned on me that with all these processes that you are taking to Boretrack, how have you seen any improvements, or how this has helped improve the drilling side for the next shot? With the consistent Boretracking, have you seen the drillers are getting better in understanding the angle side as well as the structural side, and then also the overall geology understanding? Has this been a helpful data, the Boretracking, for the geology understanding and for the geology team as well?
Yeah, it's definitely helped us out a lot, Ravi. Now that we've kind of gotten into it and everything's a lot easier, a lot of times, if I'm sending reports out to blasters, I'll send it to the driller too, because they like to see the deviation, know where the holes are going, and they're always kind of correcting themselves as they're, so they'll get one and see that their holes were deviating, 5 feet forward. And on the next shot, they're, turning their impact down a little bit, to turn the air pressure up and setting up slightly different. And they'll ask me when I show up, like, hey, how'd they look this time? Like, how's it going? So it is cool. The drillers enjoy it. They like the pat on the back when the holes look good, and they like to know what's going on and be able to adjust.
That's great. It's great to hear. We have another question here that's more related to, could you give advices on choosing the right drone for the job?
Currently, we're using the same drone throughout the company. It's the DJI Phantom 4 Pro. I believe Ravi actually recommended that. And, recently I've kind of done a little bit of research looking into, like the next drone up from DJI, I think is the Inspire and just looking at a couple different options just out of curiosity, and really can't find anything else that I think would gives us any more of a benefit than what we have currently, for how much more they cost. I believe the Phantom 4s are right around $1,600 to $1,800 brand new, and it does more than everything we needed to. The camera's great, it plenty of battery life, and we love them. We've had no issues with them.
Yeah, I mean, we fly them some pretty significant winds and rain, snow. As long as you dry them out at the end of the day, you're usually pretty good. There can be some wind situations, but they're kind of built to correct themselves and withstand the elements. So,
How long does the battery last? What size sight are we talking about? To kind of give them an idea.
If we're in like a normal day, calm winds, nothing crazy, you get about 28 minutes to 30 minutes of flight time out of one battery. On like really windy days or cold days in the winter, that can drop in half or more. You can be down to about 15 minutes. But like we were saying earlier, a general flight of a bench, just me doing a scan for boretracking for a shot, is probably only about 5 minutes of flight time. So, I would basically go through like a battery every day, and I charge it overnight. I always keep 3 on me. Some of the quarries we have, the sites, are hundreds of acres, and it can be 2 or even 3 full batteries to do like an automated full quarry scan or a flyover, as we like to call it.
Thank you.
No problem.
Great. We have another question here. What is the maximum depth of measurement inside the hole with drone for understanding deviation? Maybe I can rephrase this. I believe the question is more related to the maximum depth of measurement inside the hole. I think the drone, I can probably take this up. So in this case, the drone itself is generating the 3D model. It's not limited as long as it captures the bench height, and all it takes the measurements from there. And if we have the borehole deviation information that's coming from the bore tracking device, it just use that as a reference point for the understanding of the maximum depth. So there is no limitation there.
Except maybe the length of the boretrak cord.
Yeah, that's
the current cables we're using is 35 meters. I think it works out to be about 120 feet or so. And we've only ever run into it 2 or 3 times where we had a hole deeper than that.
Oh, okay.
At
So
that point, if you know what the first 120 feet's doing, the last 10 feet's not that important.
Yeah. Okay, we have another question here. Have you seen any dramatic changes between pre-drilling timing design versus post-survey design? I believe the question is more pre-drilling timing design versus post-blast design. Is that?
I think no, I think he's saying as designed versus as drilled, comparing the timing design for how you would lay it, how you would plan the timing for this theoretical holes versus the actual
as drilled holes. Yes. Any significant changes that you have made on the timing side after you bore track the shot?
Not only in very extreme cases. We have seen it a couple times, where with extreme deviation, where you may have a second row hole that ends up in front of a first row hole, And that, then you got to kind of switch around your timing, and you're shooting one as, what was intended to be your second row hole actually becomes your first row hole, and you got to adjust that timing accordingly. But for the most part, it's pretty much, we're just sticking with our original plan.
But loading might differ. So timing might remain the same, but loading might differ.
Definitely, yeah.
Great. Another question that comes here is that usually other members have asked previously is they bow tracking, and usually whenever you have close neighbors, does that help you in controlling the vibration issues as well?
Yeah.
So fragmentation equals lower vibration. So if if the blaster is confident in the loading because he's got the Boretrak data, and he's able to get the front row moving out in a better manner than if he was more conservative, and definitely you'll lower your vibrations, because your subsequent rows are going to be moving that much better as well. So
We have a question in the chat box. Are you able to import already processed data, or do you have to process the drone images in Strayos?
Yes, yeah, you can import the already processed data, such as GeoTIFF and the 3D model, and use that to do your analysis. Yeah, definitely. Yeah, it's a good question. We have few those workflows where they want to bring their own data set, so that's option is there. Another question here that's from the audience again, going back, is what's kind of the flight height? I think Zadok, you mentioned you're flying at 200 feet for most of your shots.
Yeah, I usually do, I'll do one pass at 200 feet, and then I'm usually down around 85 feet for the rest of it, around the bench. And then when you're actually taking the images of the face, it all depends on how high your face is, on how high you're flying it. It's a lot of height and distance calculations based on the angle of the camera. But roughly you're around 80 to 100 feet on like a standard bench. As far as like quarry flyovers, I'm usually around 300 to 350, depending on what's in the quarry. Sometimes there's a high conveyor tower or a crusher or something. You want to be sure you clear it, and I'll give it a little bit of extra.
Yeah. Thank you for the answer there. We have time for maybe one more question. So here, last one, is Phantom 4 RTK worth it? That's it depends answer here. It depends upon your workflow. If you are constantly flying large sites and you don't have time to put GCPs, then it's definitely worth it. And if you're flying even more larger areas beyond 30 kilometers, then actually even RTK, I would suggest PPK option, because that way you can have the consistency and not losing the signal from the RTK. But the decision to choose RTK or go with GCPs, it really depends upon your workflows and very site specific. And we'll be happy to chat more separately on that topic as well. So.
Also, if you're interested, we'll be doing a webinar next month or in 2 months on PPK drones.
Yeah, the PPK workflow.
Mm-hmm.
Great. We're almost the top of the hour. I want to take a time here to our guest speakers, Aaron and Zadok, for a wonderful presentation. I certainly learned a lot on the bow tracking side, how it is helping their operations, not only day-to-day basis, but also how it is making safer, and how this useful data has been integrated into their workflow. So thank you for the wonderful insights. I wanted to thank our audience here for today in asking such an amazing questions here, participating in the polls, and sticking around in different time zones and late nights here. So I appreciate the engagement here, and I believe next time we'll definitely try to balance the time so that it works for most of the time zones here. Thank you, everybody, for hopping on today. We appreciate your participation. And until then, bye.
Thanks, Ravi.
Thanks.
Thank you. Bye, guys.